we have had multiple batches in the previous years with huge success in the topics of teaching Python for oil and gas professionals. And in this series of webinars, which is going to be divided in two sections, the first section is going to be today, and the second section is going to be tomorrow. We will be showing you how Python can help oil and gas professionals in their career and creating solutions and innovative applications that can be applied on major section, or let's say on all the domains in oil and gas industry. Please, if the audio is audible and the slides are visible, please say so in the chat box so we can move forward. Okay, so everything's looking good. Okay. Python has been around since 1991. So it's in the terms of programming language, it's not the newest language, and it's not the most ancient one. It's in the middle. So whenever you hear about Python, especially people in oil and gas industry has started hearing about Python recently. So they think that it is a new programming languages, but no, it is not a new language. It's more than 33 years old by today. And basically, lots and lots of people are using this programming language for basically everything. Before we dive deeper into these details, it's good to know the instructor. My name is Nashat Omar. I am a professional production petroleum engineer. I have been working in oil and gas industry for more than 11 years. I have gladly trained more than 300 engineers and specialists on the topic of Python. Plus, I trained more than other 200 engineers on other related topics to the production and flow assurance domain. I have vast experience in programming. I have started my programming career with .NET languages, which is basically C#. It's not a hard language, but it's not a language that's developed for people who are working in oil and gas industry. So it's not very user friendly. Plus, I have good knowledge in other softwares like OFM, PipeSim, IPM packages, and Olga. So why you should consider joining our Python training, or as a matter of fact, why you should actually consider learning Python in the first place? First of all, learning Python, it's not just like you're trying to learn programming. Learning Python actually can teach you the fundamentals of problem solving through programming. And in addition to that, you will learn how actual data analysis workflows can be created, and basically you can replicate data analysis workflows done by others, plus you can invent your own workflows. You will also build a really strong data handling and data manipulations skills. Most people or most engineers working in oil and gas industry, they have this skill where they handle data. However, they are not really good at it, because in oil and gas industry, we have softwares like OFM, we have softwares like Excel, and we have software like Access, Microsoft Access, and we use those on daily basis. However, they require really steep learning curves. Plus, some things are just not achievable with these software, at least without any workarounds. Plus, you will learn how to solve problems and create solution not just for you, but also for your team, because now Python has become so mature that the solutions that you are creating will be based on something known as a web technology. A web technology is just solutions or graphical user interfaces that you will be creating that contains, or it's going to be viewed in the web browser. So once you're able to view it in the web browser, you can just share the link with anyone that you want him or her to view your solutions. Plus, if you learn Python effectively, you will be exposed to tens, well, many Python libraries that actually you will use in real world problem solving. What is good about Python and what it actually really sets it from other programming languages, it's just you don't think of Python as a programming language. Actually, Python is more like a Lego. You have everything pre-built. This means that you don't need to build anything. You will just put those missing pieces together. And this will facilitate lots of things for you. For example, you will save time, you will save efforts, plus the solution that you will create, actually, it will only take few hours. However, if it compared with other programming languages, with other languages might take anywhere from days to months. Plus, you will be able to join a large network of professionals who are already using Python for their solutions in oil and gas, different oil and gas sectors. We have lots and lots of success cases from our participants who managed to create dashboards, who managed to create solutions, managed to create data pipelines, workflows, connect to databases in different domains. For example, we have people who work in reservoir surveillance, so they tailor Python for that purpose. We have other people who work in well analysis and nodal analysis. Uh, they tailored Python for that as well. We have people who work in drilling. They have successfully managed to migrate the code that they written to be tailored for their own domain. So Python is basically very versatile. You can use it for basically everything. Now, those are why you should learn Python. But if you learn it, how can it actually impact your career? This is not strictly talking about oil and gas industry, but this is something, let's say, generally speaking. First of all, it will open a wide range of career improvement for you. For example, you can just shift from petroleum engineering to like any other sector. If you have the right skills and the right Python knowledge, you can transfer to that particular segment. And basically, we have actually success stories with participants that actually they have managed to migrate from petroleum engineering, or let's say they shifted their career to data science or equivalent data engineering. Plus, one of the most important things that I really love about Python, which is automation. If you learn Python, meaning that you can utilize it to automate boring stuff with Python. For example, maybe you want to do some reporting, maybe you want to do some emailing, maybe you want to create hundreds of, or let's say tens of plots at the same with a single click of button. But that thing is actually it's not achievable using commercial softwares or even using Excel. So you can automate these boring things with Python. You can use Python in order to create petrophysical analysis. You can use Python to manage data, create data lifecycle, create dashboards, create business insights, and create KPIs, and everything. It's going to be under your control. Plus, you can implement various projects into existing digital oil fields or existing commercial softwares. And I will touch up on this in the upcoming slides. You can use Python in order to create predictive models based on the data that you have. For example, you can use it to create time series analysis, or maybe you can use it to create clustering, machine learning, artificial intelligence. Basically, nowadays, everything that is related to the predictive modeling, it's basically done using Python. So Python is really important player in that area. Plus, one of the most important aspects of Python is actually having the ability to import multiple data files, or let's say multiple data from multiple sources at the same time. So basically that is a really huge positive thing about Python. So let's go back to the first point, which is Python. Python is actually, as we said, it was released in 1991. and it was not that huge of a language until the early 2000s. So let's say there are like 10 years of Python's life that actually, no, to be honest, no one actually used that language. Few things happened that actually shifted people's attention to Python. We are not going to touch up on those, but let me just show you what Python is now being used for. It's first of all, it's being used for web development. Actually, this is one of the things that we teach our people, or let's say our trainees or our engineers to do, which is web development. Well, the name might sound very scary, but it requires really, really minimal knowledge about web technology, because nowadays Python is so mature, you only need to write Python code in order to generate graphical user interfaces. So you don't need to know anything about HTML. You don't need to know zero about JavaScript. You don't need to know anything about CSS. Python will do everything for you. People use it for large scale software development. We see people in academia who use it for mathematics. We see people using Python for system scripting. System scripting is basically you will tell your Windows machine or your Linux machine or Mac OS machine to do specific things at specific times. So this is basically one of the things that can be related to automation. And the majority of people who use Python actually live in the category of data science. Data science is such a broad specialty. It contains basically everything. It contains data manipulation, data handling, machine learning, creating dashboards. So basically, data science is really, really uh, small term, but for huge potential and huge capabilities. Plus, we have seen people also using Python for engineering, design, and computation. We've seen solutions that actually replace softwares like ANSYS and COMSOL, which is basically used for computational flow dynamics, or just known as CFD. And we have seen packages, free packages in Python that can do that. So the basic important thing that it is actually free. That's why people started using it heavily. So why you should learn Python, or why you should consider, let's say, why you should consider Python instead of other programming languages. So let me just tell you what other options that you have as an engineer that you want to learn. Other options that you might have is actually Matlab, Python, Go language, Rust, and Java. So why Python is such an important choice for you to learn? First of all, if you learn Python, most of the things are already done in Python. So you don't need to rewrite them. You will only import them. So that's the beautiful thing about it. There is the second point, there is a really, really huge community around Python. So if you don't know anything, if you just ask online, most definitely you will get many, many answers. Plus, it's free, which is something that we already talked about. It is extremely easy to learn. Plus, it is really, really easy to share code. So some people actually, they have some hard time understanding this, why it is really easy to share the code. So back in the days, let's say that's the 70s and the 80s, programming languages were designed based on the CPU architecture, meaning that if you have some programming languages like Quick Basic, maybe you have C++, maybe you have other programming languages. So those languages were designed for really, really specific computers and really specific operating systems. But Python is not like this. So the code, and this is really important, by the way, the code you write on Windows will work on Mac OS, and it will work on Android, plus it will work on iOS. So you will write just a single code, and it will basically can be migrated to whatever machine you want. And we have different participants in our previous training that used Mac OS, and the code was like 100% compatible with their devices. So that's something that you should not concern about, because the code is 100% shareable. Plus, there are good numbers of oil and gas libraries. So what does this mean? Meaning that there are libraries that are dedicated for oil and gas users. So for example, we have a library that is dedicated for reservoir engineering. We have libraries that are dedicated for we have libraries actually that are dedicated for geomechanics. We have actually other libraries dedicated for petrophysics, production engineering. I will be estimating there are around more than 100 libraries that are related to the oil and gas industry. And some of those libraries are extremely huge, meaning that if you want to learn a single library, you might spend months just learning that library because it has like many features. And most of the time, you're not going to need all of those features. So that's the current state of Python libraries as related to the oil and gas industry. Okay, so let me show you why Python is really popular. Basically, before I learned Python, I was a professional C# developer. And in order to write something in C#, you have to define the type and then you'll just semicolon. So basically, this is the code in the middle that I have put an asterisk on. So this is a C# code. If you compare it to Python code, you can see Python is much more English-like. So it's very easy to read. It's easy to comprehend. Plus, it is easy to maintain and build on it and scale your code. And we have other language which is really recent, which is called Rust. And you can see if you compare Rust, so if you compare this Rust code with Python code, you can see Python code is really minimal, and if compared with Rust. Plus, Python allows you to fast develop things, meaning that if you want to add a new feature or maybe you want to create a new software, believe me, if you are competent in Python, you can just do it like in 30 minutes or something. So one of the things that I really love about Python is actually Python code is really different from other codes, meaning that each line will be executed and the results will get back to you just instantly. It's called interpretive language or sometimes known as dynamic language. And this is basically what is the main difference between the Python and other softwares or other programming languages like Java and C++, C#. We have many tools that we can use in order to develop Python with. Unlike other programming languages, we have specific programming languages. They does not have any huge community support, but lucky for us, Python has many great tools that we can use in order to facilitate the code writing process. One of those is actually Spider. We have PyCharm, we have Visual Studio Code, and we have basically new code editors, or let's say new development environments are coming in the upcoming years. Those are being, for example, Code Spaces and Visual Studio Code Web, meaning that those IDEs that are web-based actually don't even need to install Python in your machine. So basically everything is changing. If you want to learn Python, it does not mean that you want to go ahead and install the software in your machine. And this can be very beneficial for people who have some IT restrictions on your computer, especially if you are working with for a large corporate. Those people usually do not allow you to install foreign softwares on their machine. So what you can do is you can just use a online based or let's say cloud based Python distribution. So this is just an option that you can consider if you have some difficulties. Now, what is the relevancy to the commercial packages? So back in the days, the most important programming language was actually Fortran and C++. So we can see legacy softwares like Eclipse, like Pipesym. They usually used those languages in order to interface with different components in the softwares. But this is actually changing from I think it was from like 2017 and onwards. Pipesym, which is a flagship software by Schlumberger, it started implementing Python instead of Fortran and instead of C++. So if you know Python, you can, of course, integrate that with Pipesum in order to create automation and a file management plus network management using Python. You can use Python with Techlog, which is a petrophysical software. You can use it in order to create various workflows and various calculations. And plus, you can use it Python with Olga as well. We have seen cases, lots of people using Petroleum Expert IPM or Open Server with Python as well. This will allow you to bring the power of Python into using Gap and Prosper software. So basically, what you will do in this case actually is basically automating things. For example, if you want to calculate the optimum operating pressure at a given well or at a given selection of wells, what you can do is you can just write a script of Python that can automate this process for you and return the results for you, as opposed to just opening those files manually and running multiple times. So it's going to take lots of time, and that's why that you can actually connect Python with those softwares. You can use it with T-Navigator. You can use it with Geolog. Actually, many softwares started to adapt Python as their main language. Okay, so moving forward, and this is actually a very concise list of what libraries that you have that are actually relevant to the oil and gas industry. This is just a concise list. There are many other libraries that you can explore. So the first and foremost library is actually called Lasio. Lasio is just a library that's targeting geoscience and petrophysics. Uh, if you have enough experience working with petrophysics and you know the calculations, under 30 minutes, you can create an effective analysis for a given well or a given set of wells. It's that easy, because the most challenging thing when it comes to petrophysical analysis is actually reading the last files or reading the DLS files. And most people who worked in petrophysics, they already know that. So if I told you that Python actually takes that burden from you and packages it inside a library called Lasio with a single line of code, you will be able to read a full last file, and then you can use that last file to do anything. You can create you can use that last file to compare it with other last files. You can use last file to, for example, to create petrophysical workflow, or let's say petrophysical analysis. So basically, you can do anything with it. You can create a loop that reads more than 40, 50, 100, 500, depending on your computer power. You can read those 500 last files all at the same time, and you can use them to do various of things. For example, you can use them in machine learning. You can use them in doing different petrophysical calculations, and then you can just put everything together. Maybe you want to drive some statistics from those files. And basically, if you take a look at those capability that I'm talking about, most commercial softwares, they fail specifically at this point, because graphical user interfaces with commercial softwares, they are extremely good at providing user-friendly process or user-friendly workflow, but they really fail whenever you're starting to create automation. Some softwares will allow you to work with multiple files, but there are always those extra steps that you need to go through. And some features, they might even not work on multiple files. Okay, so this is the first one. The second one is called Fluids. Fluids, it's one of the most important libraries. It can be used to generate equation of state or even black oil properties with full-fledged tables. Another library, it's called PSAP, or it's a library that's used basically for nodal analysis on given well. It contains two correlations, which is Hager-Brown and Beck-Zumbrell, which is basically the two things that you need for pipelines and wells. You have CoolProp, which is another fluid PVT package. You have OpenPNM. OpenPNM is one of those advanced libraries that's used to model porous networks. Basically, what you will do is you will create a virtual core block, or you will create like a part of a rock, and then you will do those different simulations. For example, displacement, drainage, imbibition, those different things that you can study using Python. Plus, we have another library which is called Rockify, which is just a library that's dedicated for geomechanics and various calculations that are related to the rock strength and whatnot. This is just a really concise list. If you go online and just search for Python for oil and gas, of course, you will the first search result you will see is our course, and other results you will see is just those libraries that are just sitting there and waiting for you to use them. Okay, so these are just an examples of what you can do in Python. These are basically just examples related to the reservoir engineering. We have more examples related to production. We have other examples related to drilling. Basically, everything that you can think of, you can do in Python with really ease. And the most important part is it's easy to do and it's a lot of fun. Okay, so let's move to the second part, which is where I'm going to show you like really simple Python scripts, yet they are extremely powerful, and you can just judge for yourself how it's easy to create solutions in Python. Okay, so let me just bring up this software. Please, if you have any questions, type it in the chat box. Today, we are not going to answer any question. We will collect all of those questions and we will answer tomorrow. Just make sure to ask your question in the chat box. Okay, so basically this is a software called Visual Studio Code. Visual Studio Code is a really infamous software that's basically used in order to create Python code and then run this code. Basically, you can automate things, you can just create regular solutions. So basically everything that you want, you can do with the software. So I have a few files that are already on my radar, or let's say they are already set that we can use. For example, one of those files is called production history. This production history file contains many columns, and it contains all the data that are relevant to those well productions. You can have other files for injection. You can have other files for ratios, for example, GR water oil ratio, and basically you can have all those files all sitting next to your Python file, and you can utilize them in your solutions. So let me just show you a simple automation script that I will create in order to convert those well productions into actual plots, and I will save them in a dedicated folder. Okay, so this sounds a lot, but it will take really small amount of code to achieve this effect. Okay, so in order to do a file reading in Python, it's really simple. So what you need to do is you will import a library called Pandas, and then we will be using the Pandas library in order to read our table. So data frame equals to pd.read CSV. So this is the function that actually reads the text file. Let's provide the name of the text file, which is called production history.txt. And then we'll type the type of the separation, which is it's optional, but it's best to provide it. Once you do that, you will type df. Once you type df, you can run this file. There you go. Now you have successfully read the file and you have printed it at the same time. You can see it contains 21,000 lines of rows. And if you compare that with the Excel performance, or let's say Microsoft Excel or any spreadsheet performance, you can see Python is much faster to do that. And under 3 lines of code, because the last line, to be honest, does not count, the active line of code is actually line number 2 is actually reading the actual the file. Let me just show you how other languages treat this. Let me show you an example how C# actually implements reading file. Now, let me just pull up a result. So basically, in order to implement the same solution in other programming languages like C Sharp, you would write this much code in order to read the same file. And most of the time, the thing that you will write, it will be at its best. It will be really static and it does not provide you with any functionality. However, in just one line of code, we have managed to do that, and Python has identified different columns. Okay, so let me just show you things that you can do with this. Okay, so next thing I would love to do is actually to do some plotting. So in order to do a plotting, what you will do is you will import a library called Matplotlib .pyplot. I know the names can be confusing, but with practice, you will just get the grasp of it. Okay, so as PLT, so we are using as PLT just to change the name. And then once we do that, now we can use the PLT in order to create any plot we want. I can create a line plot. I can create a scatter plot. Basically, I can create whatever plot I want. So the first thing I will do is I will be plotting the date against data frame. Let's say, let's plot just the oil. But before we do that, let me just convert the date, because sometimes the date will give you a problem or make your performance really, really slow, because the dates sometimes are not recognized as a date. So you need to do a really small conversion for that. Okay, so data frame dot date equals to pd dot to date time. So this is just a really simple conversion. So data frame dot date. So basically this is it. Let's run the code. There we go. Now this is the plot you have. Basically what you're doing is you're plotting 20,000 data points at the same place. If you want to view it as a line plot, you will just shift this from scatter to plot. So you'll see this line plot. So however, the ugly thing about this is actually I am plotting more than 200 wells at the same time. So what we need to do is we need to create a solution that will transform this thing for me. For example, it will transfer this many plottings for us. Before we do that, before we create this particular solution, there is another thing that you can do. Is, for example, there is another library called plotly.express as PX. This library will allow you to handle multiple wells at the same time, and you can divide those really, really in a beautiful way. So let me just show you how to do that. So if you type px.scatter, or let's say, let's do a line plot, we will set the x-axis to the date, and we will be setting the y-axis to oil production. Okay, and of course, we will be using something called color. So we want the colors of the lines be denoted, or we want the color of the lines denoting the different well names that we have. Okay. So we will be waiting for the plot to show up because we are just plotting many, many wells at the same time. There we go. Now we have those different wells. We have two plots now showing up because the previous plot is also printing out. That's just no issue. Okay, now what you can do is actually you can do many, many interactions with this plot. For example, if you just double click on any well name, you can just add or just view that well, and then you can just on top of that well you can add any well you want. You can use this for comparison, you can use this for reporting purposes, but this is not a very really good thing. So what else you can do is actually you can let the well, or let each well have its own space in the plot. So this is going to be creating something like a grid plot. Okay, so there is an option that you can actually activate, which is called facet. So if you activate the facet, what it will do, it will actually divide each well into its own block, which is going to present something that is really, really similar to something known as a trellis in other languages, or it's known as a trellis in Spotfire and other business intelligence tools. Yeah, so this is just an option that also you can consider. And of course, you can do many things with this. You can change actually number of rows to consider during the plotting. For example, I can provide the data frame and I can tell it only to plot the first 1,000 points. Just I will provide it with this type of filter. And then you can see the first 1,000 points of this data frame only contains this much wells. So yeah, you can do this. Now we have less wells. Let me just show you how to divide those into each these wells into facet or trellis. So if you type facet column equals to, now depending on the name of the well, we can divide this rather beautiful plot into different segments of their own. And you can see each well has its own location in this plot. Of course, you can increase number of points. For example, let's increase it to 5,000 points. And once you increase it to 5,000 points, you will have more things to include in the plot. You can see now we have, I think it's more than 15 wells now being included. Okay. And one thing else you can make is actually you can even just limit the number of plots, or let's say the number of the columns that are showing. For example, let's just limit this to 5 columns, or let's say 5 wells at each row. So we will activate an option called facet column wrap equals to 5, meaning that with each 5 columns plotted, it will start a new row. Let's run this. There we go. Now you can see this is looking a little bit better. And this is basically all the production from all of those wells. Of course, you can just do many things with this. You can increase the size of the plot. You can decrease the size of the plot. You can basically do lots and lots of things with this. Okay, so this is basically how to do the interactive plot. Let me just go back to the automation process that we can output multiple plots at the same time. Okay, so I will just copy this part of code and I will go below and open up a new code section. So this is the beautiful thing about using Python. You will just leave the previous code and you will start a new code at the same file. So you don't need to open up a new file, which is a really good thing. Okay, so let's continue. Since we are doing this plotting, what we can do is actually we can create a loop that will loop through all the wells that we have. So let me just show you what wells we have. So if we type dataframe.uniqueID, so this will basically show you all the wells that you have sitting in the file, which you can see the total count is 21,000. But if you pay close attention, you can see lots of those names are really repetitive, meaning that you need to somehow filter out the unique wells. And this is something really easy in Python. So if let's create a loop for well in dataframe.uniqueID, sorry, dataframe.uniqueID.unique. This is that function that provides you with the unique well names. Once we do that, now it's time to actually to filter out the data frame, or let's say to filter out the table. So I will create something called table equals to dataframe.uniqueID equals to the well, meaning that each time in the loop, I will just filter out whatever well is just providing me the loop with. Okay, so once we do that, it's time to actually to reflect this on the plot. So we will type oil and date. Okay, other things that you can do is also you can provide the grid. So this will activate the grid option. You can provide the title. So this will activate the title option. For example, we will provide it with a title called well. With this, actually, the title will be the name of the well. And this is going to be dynamic because it's inside the loop and it's going to be different each time you run this loop. And this is the beauty of Python. It will automate lots of things and make this thing really easy to accomplish. Okay, let's just add another variable. Let's just add the gas plotting as well. So table.date and table.gas. Now we have two variables. Let's just give them names. Otherwise, we are not going to recognize them. So let's call this oil. Let's call this gas. And I'm sure you all guys know that usually the oil and gas, they are not compatible in scale. And instead of just going and creating multiple y-axis, for simplicity, I will just convert this into a logarithmic scale. So plt.y scale, which is going to be log. And you can see how simple it is. And once you do that, it's time actually to save those plots that are being generated on the fly. So you will do plt.save fig, which is a figure saving function. I have a folder called history. So let's go use that folder. And then for the name of the well, I will be using the name of the well that are coming from the loop. So this way I make sure that a well name is properly assigned to the saving figure. So let's just go ahead and try this solution. Let's run the code. Let's open the history. You can see new images started to appear on the history folder. Let's go to our history folder and let's just put this side by side with Python code, and you can see it's constantly generating new values. So let me just make this as a detail. You can see as of now, it generated more than 20 plots, and it's still generating. It will not stop generating plots until the names of the well will finish from this file. Okay, so you can see it's constantly generating plots. Let's just give this 1 minute, or let's say less, to finish up. If you don't want this code to continue spitting out files, what you can do is you can just press on this stop button. So once you press on this stop button, this will stop the Python execution. Okay, so let me just show you one thing you can do. You can open up a Word file. Let me just open up a Word file for you guys. I will just select all those plots and then I will drop it in this Word file. Let's just drop everything in here. And there we go. Now you can see all the plots now are visible inside this file. And of course, you can automate this process of adding those into the Word file. This is just something that is really, really simplistic to do. Okay, so this is basically the first solution. Let me just show you another solution that we have created 1 month. I think it was last month. We had a Python training for reservoir engineers, and basically our trainees, believe it or not, under 4 days they created this 70 line of code, and this 70 line of code, believe it or not, it creates a ARPS decline curve analysis. And the beautiful thing about this, it contains two methods of solving this equation, which is finding the production decline over time. The hard part of this types of project is actually this equation contains three unknowns. So in order to solve the three unknowns, it's extremely hard to do in other languages. But in Python, it's really, really simple to do because we have dedicated libraries that can do that. And let me show you, once you run this software, what it will generate. Let me just show you what the software does. So basically, these 70 lines of code, once they're run, it will generate this application for you. And this application basically is called Dashboard. Dashboard, this is based on web technology. And this is something I will not say it's new to Python, but it became mature enough for oil and gas people to start using as their daily drivers for data analysis, especially if you're working with a company that it's really strict on budget and they don't want to purchase uh, commercial softwares. And believe it or not, this solution was created under an hour alongside with teaching. So let me show you how this works. Basically, you have a list of wells. This list of wells is actually being generated using Python. You don't need to know anything about HTML or CSS or other web terminologies. So you will select the well and you will go to automated fitting. You can see Python has automatically calculated a fitting line for you. And this is basically the best fit line if you go to automated fitting. Let's select another well. You can see now the shape of the fitting has changed. Why is that? Because it's different data set. What else you can do is if you're not trusting the way the library is fitting your data, you can go to manual fitting. And using those levers, or let's say using those sliders, you can actually manipulate the way Python is be fitting those data. And having this tool at hand, actually, it can basically teach you lots of things about decline curve analysis equation because it will allow you to manipulate all the aspects about the decline curve calculation. What else you can do is you can just eliminate any data that you think it's actually doing a miscalculation for you. So for example, if you take a look at this portion of data, which is extremely stable. So what I will do is I will force the calculation of this fitting to start from the year of 1999, which is where our stable production is coming from. And once we do that, we can just change the data fitting so it can actually fit our data. This is just a manual fitting. You can do whatever you like with this. You can compare your manual fitting with your automated fitting. Once you finish up your fitting, you can just go to forecasted values. Those are the values that we are calculating on daily basis, or let's say on monthly basis. And then we are calculating a cumulative production at the end of a given number of months, which is it's going to be specified in here. And this is possible using Python, believe it or not, under 75 lines of code. The solution was found for decline curve analysis equation. Plots were generated, different fitting techniques was implemented, and plus the graphical user components was also programmed. And it only took us just an hour alongside with teaching. So you can see what different solutions can do for you and your career if you learn Python properly. So this is the end of today's webinar.